Imagine the last time you jumped. Within that fraction of a second at the top, before you came back down, your body was suspended between two worlds. There was no pressure on your feet, no weight in your chest, and for one brief moment, nothing was pressing against you from any direction. Then the ground came back up to meet you. You have spent your entire life believing that something pulls you toward the earth as you climb out of bed every morning, when you set a glass on a table, and every time you trip and hit the floor, you feel it and call it gravity. You move on without a second thought. But what if that is the most costly assumption in the history of science? What if gravity does not pull at all? What if the only reason you are not floating right now is that the floor is hitting you from below at 9.8 meters per second squared, and the fall you have been waiting for has already been happening to you every second of your entire life? The astronauts on the International Space Station are not escaping gravity because gravity up there is still 90% as strong as it is under your feet right now. We are floating because we are falling continuously in a circle, moving sideways fast enough to miss the Earth every time they fall toward it. And this is not zero gravity or free fall. And the difference between their experience and yours is not the force, but the floor. This is the conclusion of the most precisely tested scientific framework in history, and it changes everything you thought you understood about the ground beneath your feet. Before we go any further, if you want to understand the universe the way it actually is, and not the way your textbook described it, hit subscribe right now and join Science Download. Because this channel does not do surface-level science. This is where we take the questions everyone thinks they already know the answers to, and show you how deep those questions actually go. If you are ready to have everything you know turned upside down, you are exactly where you are supposed to be. Level 1. The Newtonian Trap. For 300 years, we lived in Isaac Newton's world, and it was a good world to live in. Newton gave us one clean, powerful idea in 1687 that every object with mass pulls on every other object with mass, which means the bigger the object, the stronger the pull, the double the distance between two objects, and the force between them drops to a quarter of what it was. This single rule explained why the apple hits the grass. It explained why the moon orbits the Earth instead of flying off into space in a straight line, and it explained why the ocean tides rise and fall twice every day, pulled by the moon passing overhead. In 1846, two astronomers working independently, John Couch Adams in Britain and Urbain Le Verrier in France, used Newton's equations to predict the existence of a planet that had never been seen. They told astronomers exactly where to point their telescopes, and within days, Neptune was discovered precisely where the math said it would be, which tells us that Newton's gravity had reached across the solar system and found a hidden world using nothing but arithmetic. NASA used Newton's equations to calculate the trajectory of the Voyager 1 probe, launched in 1977. This spacecraft used the gravity of Jupiter and Saturn as a slingshot, bending its path and accelerating without using any fuel. It is now over 23 billion kilometers from Earth, still on course, still responding, and that was due to the precision that was built on Newton's math. But Newton himself had a secret. He admitted openly that he could write the equation and calculate the result to an extraordinary precision, but he could not explain how gravity actually worked and how the sun, sitting 93 million miles away, completes a vacuum with nothing in between, reaching out and still holding the Earth in orbit when nothing is connecting them at all. Newton called this problem action at a distance, and admitted in his own words that it was an absurdity that no man with a competent faculty of thinking could ever fall into. He was not being modest at all. He was confessing that his own theory had a hole at its center that he could not fill. And for over 300 years, that hole stayed open. Level 2. The fabric. In 1915, Albert Einstein filled the hole, and in doing so, he removed the force entirely. Einstein's starting point was a thought experiment he later called the happiest thought of his life, which was a person falling from a rooftop while feeling no weight at all in this position, No force acts on their body in the moment of free fall, and by the laws of physics, a body that feels no force is in the most natural, undisturbed state in the universe. It is not being acted upon by anything, and the person falling from the roof is, in the language of physics, perfectly still. NASA operates a modified aircraft called the Weightless Wonder, where pilots fly it in steep, parabolic arcs, creating about 25 seconds of free fall inside the cabin on each arc. Passengers and objects float, and every physical sensation of gravity disappears, not because the aircraft left Earth's gravitational field, which it did not, but because the aircraft and everything inside it is falling together. The force has not changed, but the floor has simply stopped getting in the way. If the falling person is undisturbed, then the person standing on the ground must be the one under the influence of a force. The ground is pressing upward against their feet at 9.8 meters per second squared, and that upward push is the only real force in the situation. The pull of gravity is not a pull. It is your body being stopped from following its natural path. But if there is no pulling force, what now shapes the paths of planets and apples? Einstein's answer replaced Newton's invisible rope with something far stranger, which says space is not empty, but fused together with time into a single four-dimensional fabric called spacetime. Mass does not just pull at objects, but bends the fabric itself. Now imagine two people standing side by side on the equator and both walking due north in a perfectly straight line with no force acting between them, and neither one turns. Yet after thousands of miles, they will meet at the North Pole. The surface they walked on was curved, and their straight lines converged because of the shape of the ground, not because of any force between them. Scientists call these curved, straight-line paths geodesics, and in Einstein's universe, every falling object is simply following its geodesic through warped spacetime. The real-world proof came in 1919 when British astronomer Arthur Eddington photographed stars near the edge of the sun during a solar eclipse with the sun's light blocked. Stars that should have been hidden behind it became visible because the sun's mass had bent its light around it. The deflection was exactly twice what Newton's theory predicted and exactly what Einstein's theory required, and Newton's world ended that afternoon. Today, astronomers use this same effect routinely, where clusters of galaxies act as giant lenses, bending and magnifying the light from objects billions of light-years behind them. The Hubble Space Telescope has photographed dozens of these Einstein rings, arcs of distorted light that could not exist if gravity were a simple pull between objects. Level 3. The time engine. The trampoline analogy is useful, but it is missing the most important part of what Einstein discovered. Gravity does not just warp space, but warps time, and the closer you are to a massive object, the slower time moves around you. It is a measured, confirmed physical fact called gravitational time dilation, and it is built into the devices you carry in your pocket every day. The GPS satellites orbiting Earth right now sit roughly 20,000 kilometers above the surface at that altitude, far enough from Earth's mass, and time runs slightly faster for them than it does for you on the ground. The difference is 45 microseconds per day, which sounds like nothing, but 45 microseconds of timing error spread across a satellite moving at 14,000 kilometers per hour translates to a positional error of 10 kilometers by the end of a single day. If GPS systems did not run a continuous correction using Einstein's equations, every navigation app on Earth would be useless within 24 hours. The correction is not a bonus feature, but a requirement that Einstein's 1915 theory of curved spacetime is hardwired into the infrastructure of the modern world. In 1971, physicists Joseph Haffel and Richard Keating placed extremely precise atomic clocks on commercial aircraft and flew them around the world in both directions. When the clocks landed, they compared them to identical clocks that had stayed on the ground. It was discovered that flying clocks had measured a different amount of time than ground clocks, which is not much, but the difference matched Einstein's predictions precisely. accounting for both the aircraft's speed and the difference in altitude. Time had genuinely ticked at different rates for the clocks in the air and the clocks on the ground. And this is the real reason things fall, because objects do not fall because they are being pulled toward the center of the Earth. They fall because the Earth's mass creates a gradient in the flow of time, and every object in the universe naturally moves toward the region where time flows more slowly. So when you drop an apple, it is not going down, but going toward the place where time is slowest. It is falling toward yesterday. Your head is measurably older than your feet right now. The top of your body sits slightly further from Earth's mass because time moves fractionally faster there than at the floor, and the difference over an entire lifetime is less than 90 nanoseconds. But it is real. It has been measured in laboratory experiments, and it means that the weight you feel is not a force reaching between two objects. It is the geometry of time pressing against the soles of your shoes. Everything we have covered so far has been about objects moving through curved spacetime. What comes next is different, because there is a location in this universe where the curve does not bend, but drops. Where the direction inwardly stops being a direction in space and becomes a direction in time. And once you cross that line, falling is no longer something happening to you. It is something you cannot stop any more than you can stop tomorrow from arriving. Level 4. The ground is rising. Before we get there, one more inversion needs to land, and this is the one that changes everything about the weight you feel in your body right now. Now think about stepping into an elevator and pressing the button for a high floor, and the moment it starts moving upward, your stomach drops and your legs feel heavier. You press into the floor because the extra weight you feel is real. The floor is accelerating upward beneath you, and your body is resisting that acceleration. Einstein's equivalence principle states that this feeling is physically identical to standing on the surface of the Earth. There is no experiment you can perform inside a sealed room that would tell you whether you are standing still on the ground or being pushed upward by a rocket engine at 9.8 meters per second squared, because the physics of both situations are the same. The same principle works in a car. When the driver accelerates, everyone in the car gets pushed back into their seats. No one is pulling them backward. The seat is pushing them forward, and their body is resisting the change in motion. Gravity on the surface of the Earth is the same sensation. The ground pushes up. Your body resists. You call it weight. When you drop a ball in Newton's world, gravity pulls it downward toward the Earth. But in Einstein's world, the ball does nothing but sit perfectly still in its natural inertial state, following a straight path through curved spacetime, and the Earth's surface accelerates upward and meets it. You do not drop a ball and watch it fall. You simply release it from the force that was holding it up, and then the ground rises to collect it. In 1971, Apollo 15 astronaut David Scott stood on the surface of the Moon and simultaneously dropped a geological hammer and a falcon feather from the same height. On Earth, the feather would drift slowly down while the hammer hits first. But the Moon has no atmosphere, so there is no air resistance, which makes both objects hit the surface at the exact same moment. Every object falls at the same rate, not because gravity pulls harder on heavier things, but because all objects are simply following the same curved path through space-time, and nothing is being pulled at all. You feel heavy not because something is pulling you down, but because something is constantly pushing you up, and the floor beneath your feet is the only real force in this room, which has been acting on your body every second of every day of your entire life without you once questioning it. Level 5. When the curve becomes a cliff. Gravity shapes everything at the scale we live, but the universe also contains places where Einstein's geometry does not bend. It drops. Carl Schwarzschild was sitting in the trenches of World War I in 1915, the same year Einstein published General Relativity, when he solved the field equations and discovered something Einstein himself refused to believe. If you compress enough mass into a small enough space, the curvature of spacetime becomes infinite. When you compress the entire Earth to the size of a marble, you have crossed that threshold. When you compress the sun to a sphere 3 kilometers across, you get the same result. But what you have is a point where the fabric of spacetime does not curve. It collapses inward faster than light can travel through it. This phenomenon is called a black hole. The boundary is called the event horizon, and it is best understood not as a wall, but as a waterfall. Imagine you are swimming in a river, and the current is slow enough that you can swim against it. But when the river accelerates toward a waterfall at the end, at some point, the current becomes faster than you can swim. And no matter how hard you stroke, you are still moving downstream. The event horizon is that point because it is not a barrier, but a current. And once you cross it, the geometry of spacetime no longer contains a direction that leads back out. The rules of spacetime invert completely inside the event horizon, and the inward direction that moves toward the singularity at the center stops being a direction in space, but becomes a direction in time that is not moving somewhere. In 2015, LIGO detected gravitational waves produced by 2 black holes merging 1.3 billion light-years from Earth. And in the fraction of a second of that collision, the merger radiated more energy than every star in the observable universe was producing at that same moment combined. The geometry of spacetime itself was rippling outward from that event and passed through the Earth over 1 billion years later, stretching and squeezing the planet by a distance smaller than the width of a single proton. And LIGO detected it. Einstein had predicted gravitational waves a century before we built a machine sensitive enough to feel them. Level 6, the unfinished equation. And here is where the story breaks. Einstein's General Relativity theory is one of the most precisely tested theories in all of science. Every prediction ever made, from Mercury's orbital drift to the bending of starlight, to gravitational time dilation, to gravitational waves and black hole photographs, was confirmed. And yet, it is still incomplete. Gravity has not been absorbed, and it still stands alone. At CERN's Large Hadron Collider, physicists smash protons together at 99.9999991% of the speed of light. The math governing those collisions is quantum mechanics, and it works with extraordinary precision. But gravity plays no role in those calculations, because at the scale of subatomic particles, gravity is so weak that it is essentially unmeasurable. When physicists try to write a quantum version of general relativity, the math produces infinite values that mean nothing and solve nothing. Every attempt to describe what gravity does at the scale of a single atom ends in equations that break apart. We can tell you why an entire galaxy bends the path of light passing near it, but we cannot tell you how a single electron experiences the curvature of spacetime, and it has become one of the largest unsolved problems in physics, unsolved for over a century. We have mastered the gravity of galaxies, but we cannot explain the gravity of a single particle. This is the difference between a description and the truth, and the hierarchy is not yet finished. Dark energy does not appear anywhere in this countdown because it has no dramatic name. It sits at no single location in the universe because, in the most literal sense, you can point to it. But it is the dominant force shaping the fate of everything. In 1998, 2 independent teams of astronomers studying exploding stars called supernovae made a discovery that nobody expected and saw that the universe is not slowing down as gravity gradually pulls everything back together. The galaxies were seen flying apart faster and faster, driven by something spread uniformly across all of space, pushing outward with a pressure that overwhelms gravity at the largest scales. They called it dark energy, and it accounts for 68% of all the energy in the universe. We do not know what dark energy looks like, but we know it exists only because the math of gravity stops working at cosmic scales without it. The same framework that predicted gravitational waves and photographed black holes tells us that something is out there, filling all of space, reversing the pull of gravity at the largest distances, and accelerating the universe toward a final, cold dispersal that will happen billions of years from now. We cannot detect it directly, nor can we produce it in a laboratory, because we cannot explain what it is made of. So, the most dangerous force in the universe is neither the black hole nor the gravitational wave. It is not even the geometry of time bending beneath your feet, but the very thing filling all of space right now that no instrument has ever touched, and no theory has ever fully explained, and that is quietly determining the final shape of everything that exists. So we begin with a question so simple that most people stop asking by the age of 10. Why do things fall? We arrived in a universe where falling is the most natural state of motion, where the weight in your body is the ground refusing to let you follow your path, where time runs slower at the bottom of the stairs than at the top, where the direction inward toward a black hole is the direction of the future, and where 68% of the universe is made of something that defeats every theory we have ever written. So, which one disturbs you more? Firstly, that we know enough about gravity to land a spacecraft on Mars with precision measured in meters, or that the force holding the universe together at the largest scale is something we still cannot name. Drop it in the comments and tell us why, and if this changed how you think about the ground beneath your feet, the next video will take you somewhere even the light cannot follow.